This is the second part of 3.1. Classifying the system without graphing. So you are going to do very similar to the starting point, where you have to get y alone, but we're not having to go any further. We're going to talk about 3 new terms that we're going to be dealing with. Independent is when there is one solution, so in other words, when your lines cross. So independent has one solution. Dependent has, when we graph it, we end up tracing over the line. So when it's exactly the same line, graph twice. And that's the infinitely many solutions that we represent with a line. The equation of the line. And inconsistent is the last one, and that is when we have no solution. So this is when the slopes are same and B is different. On that dependent one, that's when the slopes were the same and B is the same. So it's same and same. So all you got to do is you get it solved for y. So we're going to take each of the equations and we're going to solve them one at a time. So taking the first one, 3x plus y equals 4. I want to first get the x to the other side. And remember how I talked yesterday that I like this put in the front, so when I rewrite it, I am going to put it first. So y equals 3x. My 4 doesn't have a sign in front of it, so that means it's positive. And I have y alone. Now I'm going to take the second equation and do the similar idea. X minus 1/3 y equals 1. And so I'm trying to get y alone. So I first move my y-intercept to the other side, or move my x to the other side by subtracting x. And then I solve for y. So I have negative 1/3 y is equal to negative x plus 1. Now, when I divide by a fraction, that's the same as multiplying by its reciprocal. So I'm going to multiply both sides by the reciprocal of negative 1/3. So I'm going to multiply both sides by negative 3 over 1. And that gives me y is equal to, when I distribute that through, 3x minus 1. So now I want to compare between the two equations I have. My slopes are the same, but my y-intercepts are different. So same slope, different y-intercept means that we have that parallel or inconsistent. So this is an inconsistent set of graphs. That means there's going to be no solution. We're going to do the same thing for this new one. And so we have taken the first equation, 2x plus 3y equals 1. So I want to get y alone. So I am going to subtract the 2x from both sides. And again, I like this in the front. So whenever I rewrite it, I'm going to write it as 3y is equal to negative 2x plus 1. Now I am going to divide by 3. And I could write it as all the way across, but typically we write it on dividing each term because we are going to be looking at graphing each of these. And so y equals negative 2/3 x plus 1/3. Now in the second equation, we have 4x plus y is equal to a negative 3. I want to get y alone, so I need to move this case just the 4x over. Again, I like to put this first, but this time my 3 is negative, so it's going to be y equals negative 4x minus 3. Now comparing my two equations, my slopes are different. If my slopes are different, then it is a independent system. That means they are going to have one solution. When I graph this, I should get a point they're going to cross. I don't have to look at anything else. If the slopes are different, I stop. I know it's independent. The last set, we get y alone, and the first one is really nice to us. It already has y alone. The second one, we have to do some work. And so we have 6x minus 3y equals 9. So step 1 is to move your x to the other side. Subtract 6x. I like that written first. The 9 is positive. So when I rewrite this, I write negative 3y, because that minus sign comes with it, equals negative 6x plus 9. Now I'm going to go through and I am going to divide each term by the negative 3. And that leaves me with y equals a positive 2x minus 3. Now, my equations are exactly the same. So that means that we are going to have a graph that is overlapping. Both my slope and my y-intercepts match. So that means this is exactly the same line. That is when you have the dependent solutions. That means they are going to be the exact same. That means you have the infinitely many.